Just a few things to wrap up the semester with. We're going to talk about a couple more of the enteric microbes and a couple more viruses that infect the liver. We'll mention just a few that cause wound infections, and then that'll probably wrap it up for us. I have a little way for you to make 10 bonus points. I'll tell you about that before you go out the door tonight, but that'll be a little incentive for you to stick around. So we were talking about microbes that we find in the intestines. E. coli was one that we mentioned. The Enterobacteriaceae is a group that really consists of a number of lactose-fermenting bacteria, and some have gone on to suggest that, in fact, all the members of the Enterobacteriaceae may be closely related, if not from the same species. We talked about E. coli. Let's turn our attentions now to Shigella. We've talked a little bit about Shigella. It produces diarrhea. It does so by producing an enterotoxin. There are 4 species of Shigella. All of them can cause dysentery, generally associated with poor hygiene. Doesn't take very much to cause an infection, though. Only about 200 cells serve as an infection dose because they can resist the stomach acids. Shigella is going to colonize the small intestines, and there its toxin is going to cause diarrhea, mediate diarrhea. Shigella will eventually make its way to the small intestine, or excuse me, the large intestine, where it's going to induce endocytosis. So it's going to cause the large intestine cells to take it out. There it's going to multiply in the cytoplasm. And if you remember our discussion about Shigella earlier in the semester, Shigella has a unique way of moving from cell to cell. It uses the actin filaments of the cell itself, if you will, to propel it into the neighboring cell. So it can avoid exposure to macrophages by moving from one cell to the next. And so this leads to the death of these cells here. Bacteria can enter into the bloodstream, but then if they do so, they're generally quickly phagocytized. They don't have as good a mechanism once entering into the bloodstream of resisting our immune system as they do hidden in the cells, hiding in the cytoplasm of the large intestine epithelial cells. Treatment really is replace the fluids that you're losing. And that's going to be the case anytime we're dealing with diarrhea. Brings us to Salmonella. Now, we've talked a little bit about Salmonella already this semester. You know, it's one of those microbes that's common foodborne, causes foodborne illness. It's a microbe that is spread via the fecal-oral route. And it was a major problem in the 1800s. We talked about this a little bit as well. In 1858, the Thames River was so polluted, filled with raw sewage and stuff, the smell was so great that Parliament couldn't carry out their functions because of it. Edwin Chadwick at the time had already championed the notion of a sanitary system, a removal of sewage to a local site where treatment could take place. But up until that point, they were still dumping their raw sewage into the Thames. And the thing about Salmonella is that we know it is easily spread in situations where there is squalor, where you've got high density people, where you've got slums, where you've got a lot of unsanitary conditions. And that was the case in London, was the case in New York, was the case in major cities throughout the world. it wasn't until the late 1800s that they actually identified the microbe that was responsible for causing salmonella illnesses, and specifically typhoid. Typhoid fever was a major killer in the 1800s. You might have heard that Prince Albert died of typhoid fever. There's some debate about that now. He might have died from Crohn's disease or colon cancer, but they believe it could have been typhoid fever as well. They identified the microbe that caused typhoid fever, Salmonella typhus, and then took measures to inhibit exposure, prevent exposure. So we saw, as sanitation methods improved, that the incidence of typhoid fever began to decline. But you always had to deal with individuals that wouldn't quarantine themselves or wouldn't do what was being asked. And that brings us to Typhoid Mary. True person, her name was Mary Malone. I don't know if I'm saying her name right. And she, what did I do with my water bottle? She had contracted Salmonella typhoid, and she was a cook, a good cook, and she worked in a lot of the more upper class homes. But everywhere she went, typhoid fever followed her. She was identified as a carrier of typhoid. Didn't make her sick. She survived it just fine. But those that became exposed to it, many of them died. Identifying her as a carrier, they quarantined her, put her in jail for 3 years. Then they gave her an option. She could have her gallbladder removed and promised to not cook anymore, one or the other. You know, she did neither. She didn't have her gallbladder removed, and she continued to cook, continued to infect people. And so they arrested her again and put her in a solarium, I think it's a sanitarium maybe. Where is it? Anyway, they put her away. They just say that they put her in quarantine. I'm not sure exactly what that meant, but that's where she died, in quarantine, because she refused to take the measures necessary to stop infecting people. They don't really know how many people she infected over the several years that she remained a cook, moving from one house to another house, and a lot of times she would, as soon as the sickness started to take on to the family, you know, she would move on to a new family.
What was the gallbladder having to do with that?
I don't know, you know.
They thought it had something.
I don't know. I'm not sure, because that's not the only route of, you know, exiting. So I'm not sure what that would be. Hepatitis is would lead via the gallbladder, but I don't know about maybe hepatitis. I don't know. Anyway, so Salmonella. There's about 2,400 strains, all identified by a different serotype. So, do you understand what I mean when I say this then? If there are 2,400 different strains of Salmonella. And again, there is contradiction about how separate these strains are. Serotype then. So what we're talking about is that each of these different strains has an antigenic epitope that's different than all the others, right? So that means that they're going to generate antibodies, different antibodies.
So then is typhoid one of the serotypes of salmonella?
I'm sure it's one of them, yeah.
It's one of the 24.
Yes, absolutely. Okay, so we'll leave it at those bacterial infections of the lower digestive tract. I want to move on to a couple of viral infections. You can have viral diseases of the lower digestive tract that cause, flu-like symptoms, stomach flu-like symptoms. You're probably familiar with them, the rotavirus or the Norwalk virus that you hear about on cruise ships all the time. They generally attach to the epithelial cells of the upper small intestines, the large intestines as well. Often making children sick, causing flu-like symptoms, nausea, vomiting in children. And again, hand washing is going to be very effective in preventing the spread of the virus. Hepatitis is an infection of one of the accessory glands of the digestive system. There are three types of hepatitis here. We're talking about an infection of the liver that destroys liver cells, destroys the function of the liver cells. It can lead to cirrhosis. Three types, as I mentioned. First one is hepatitis A. Hepatitis A is an infectious hepatitis. It's endemic around the world, so all populations experience cases of hepatitis A. It could be a candidate for eradication because it's restricted to the human population. So the virus replicates only in the liver tissue, and it exits via the gallbladder, as we were just talking about. We do have a vaccine for it, but there's no antiviral treatments. And then it's spread via fecal-oral route. Again, fatigue, fever, loss of appetite, nausea, jaundice. A lot of conditions that affect the liver lead to jaundice. Jaundice is a yellowing of the skin due to the fact that the liver is no longer breaking down bilirubin and bilirubinin. These are the two compounds that are used to make red blood cells, and a lot of the liver is processing red blood cells, breaking down old red blood cells. And when it's not functioning correctly, those two compounds, bilirubin and bilirubinin, end up in the bloodstream, and that causes the yellow tint that you see. Yeah. The reason babies are jaundiced right after being born is that their liver isn't completely functioning such that it can break down the bilirubin and bilirubinin. Hepatitis B. This is serum hepatitis. Probably responsible for about 40% of all hepatitis cases. We have about 1.25 million in the United States. 5% of the cases worldwide are hepatitis B. 9th leading cause of death. Symptoms are similar to A, but they're going to be much more severe. So it's a blood-borne disease. It's going to make its way to the liver via the bloodstream. It can cause cirrhosis. If you're not familiar with what cirrhosis is, it's this damage to the liver cells that then get replaced by scar tissue. Scar tissue doesn't work to do what it's supposed to. It doesn't work like liver cells do. Or it can cause cancer. Again, that then is going to be cells that are replicating uncontrolled. And the problem with that is that you've got these cells that are replicating uncontrolled, but they don't do what they're supposed to do. Even though they might be replicating, they're not carrying out their functions. Hepatitis B is spread by blood and semen, blood transfusions, minor injuries. If you get blood transfusion, minor injuries. 50% 50% of all cases are sexual intercourse, though. We do have a vaccine available. Extreme care should be taken by those that handle blood. You certainly don't want to, if you draw blood or something, want to make sure you don't accidentally poke yourself. Again, we don't have any antiviral treatment for it. And then that brings us to hepatitis C. Hepatitis C, again, is a blood-borne virus. You have to be exposed to contaminated blood. Again, if you're a health worker working with blood, you have a greater risk. This is the most common chronic blood-borne infection. About 3 million Americans suffer from it. It'll affect the liver and it'll incite an inflammatory response. So you get an immune response that gives you fever, you know, the accompanying symptoms that go with that, and you'll get this oscillating situation where you'll have symptoms, fever and fatigue and malaise from the conditions, and then you'll